This is a video for AQA Further Pure Mathematics. Hyperbolic Functions, Section 2.4, Integration using Hyperbolic Substitutions. We've probably seen in previous videos how trigonometric substitutions can be used for some particular types of integrals. We're now going to look at similar methods, this time using hyperbolic substitutions. So for example, something like x squared minus a squared, the square root of that, can be found usually by using a substitution x equals a cos u. And that's because when we make that substitution into here, we're going to end up with cos squared u minus 1, which we can then use an identity and produce an integral which can be found quite reasonably easily. So let's look at a specific example of this. So here we're asked to find the integral of square root of x squared minus 9 dx, and we're told to use a substitution of the form a cos u. Well, if we actually use x equals 3 cos u, then what will happen is that we'll get 9 cos squared u minus 9 inside the integral. So we'll be able to take the 9 as a factor outside of the integral. So let's look at that in practice then. We get the square root of x squared minus 9 dx. And if we make the substitution, this will be equal to the square root of 9 cos squared u minus 9. That will be dx du. So remember, when you make the substitution, dx becomes dx du. And now we can take out that 9, so we end up with, when it comes outside the integral, 3 multiplied by the integral, and then inside we've got cos squared u minus 1. And then dx du. Well, inside the square root, cos squared u minus 1, that's equal to sine squared u. And we can get dx by du by differentiating, so we can see if x is equal to 3 cos u, then dx by du is equal to 3 sine u. So making those substitutions, we can say that our integral then becomes 3 multiplied by the square root of cos squared minus 1 is the square root of sine squared, so that is just sine u. And then dx by du is 3 multiplied by sine u, and that is now our new variable du. So in total, once we've made the whole of the substitution and simplified it, we end up with 9 times the integral of sine squared u du. So let's just look at that one more time. We've got x squared minus 9, so recognizing the fact that if we make the substitution 3 cos u, then that will give us a factor of 9, which we can take outside the integral and the square root to become 3, leaving with us with cos squared u minus 1, which we can change by the substitution sine squared u, and dx by du is 3 sine u. So we end up with this to integrate with respect to u, sine squared u. The sine squared is not something we can do directly, however we can use this identity to see that sine squared u is equal to cos 2u minus 1 over 2. So half of cos 2u minus 1. Therefore this integral becomes 9 over 2 multiplied by the integral of cos 2u minus 1 du. And now both of those are things that we can integrate quite easily, so that we get 9 over 2 cos 2u becomes 1/2 of sine 2u, and 1 of course integrates to u, so we get 9 over 2 1/2 sine 2u minus u plus constant of integration c. This of course is a function of u, and we want to be able to get it as a function of x, so we need to reverse the substitution. Before we do that, however, we've got to deal with sine 2u, so there's another identity that we can use. Sine 2u is 2 cos u sine u, so instead of 1/2 sine 2u we get cos u sine u, so this is equal to 9 over 2 cos u sine u minus u plus constant c. We can now look at reversing the substitution. So we use the substitution x is equal to 3 cos u. Therefore we get that cos u is equal to x over 3. We can use the fact that then sine u, well, sine squared is cos squared minus 1, so sine u is the square root of cos squared u minus 1. So that must be equal to the square root of x over 3 all squared, which is cos u, so that's x squared over 9, and then minus 1. So that will deal with the cos u and sine u. Now we've got to think about u. Well, if x is 3 cos u, u must be equal to cos the minus 1 of x over 3. So making those substitutions, then we can say this is equal to 9 over 2, and cos u is x over 3, sine u square root of x squared over 9 minus 1, and then we've got minus 9 over 2 multiplied by u, which is cos the minus 1 of x over 3, and plus c. Now we can tidy that up a little bit by realizing we can take out a factor of 1/9 from this bracket here, and when it comes out the square root, that will become 1/3. So we're going to have 9 over 2 multiplied by x over 3 multiplied by 1/3, so that's x over 9, and inside the square root we've taken out the 9th, so that's x squared, and thinking about 1 as being 9/9, that must be therefore minus 9. Then we've got minus 9 over 2 cos the minus 1 x over 3 plus c. The 9th cancel out, so that finally we end up with our answer x over 2 square root of x squared minus 9, then minus 9 over 2 cos the minus 1 x over 3 plus c. Just checking back through those steps, then we started off with the integral of sine squared, and we could use this identity to change it to cos 2u minus 1, which we could then integrate quite straightforwardly. Needed the second identity to change sine 2u to cos u sine u. Once we've done that, we need to look at the reverse substitutions. So we had that cos u was equal to x over 3, and then using the sine u being the square root of cos squared minus 1, and also u is cosh to the minus 1 x over 3. All of those then came from the fact that the substitution we'd used in the first place was x was equal to 3 cosh u. Making those substitutions, we ended up with the final answer of x over 2 x squared minus 9. There's that little step there of taking out the factor of 1/9 from the square root just to make it tidy, although strictly speaking then it really depends on what you've been asked to do in a question. The answer is finish at this stage, and this last part is just tidying it up to make it look a little bit neater. Well, that concludes this video on hyperbolic substitutions. In the next video we'll be looking at some further hyperbolic functions.